Mission Atlantic, to ensure a sustainable future for the Atlantic Ocean. Integrated Ecosystem Assessment, or IEA, is a holistic approach to managing ecosystems by evaluating the cumulative impacts of natural variation and human activities. It follows an IEA loop that starts with scoping the system, together with stakeholders developing indicators, analysing the risks from and to different parts of the system, testing potential future scenarios under natural and anthropogenic change, and refine focuses on revising and improving the assessments based on the outcomes and insights gained from earlier stages in the cycle. This process helps balance trade-offs between ecological health, social well-being, and economic viability, ensuring sustainable use and conservation of ecosystem services. The indicator development phase is crucial for monitoring the health and trends of the ecosystem. By developing and selecting robust, relevant metrics to monitor ecological, social and economic dimensions, managers and decision makers can identify and respond to developing challenges in an informed and timely manner. In this video, we consider how to handle the empirical data that underpins the analyses of an IEA. Our guide, William, takes us through how to find and identify trustworthy existing data, as well as how to collect and compile data that is relevant for the IEA, including data sources that are not publicly available. Furthermore, William demonstrates the utility of a metadata catalogue for supporting repeatable science, finding gaps, and collaborating more broadly.
Hello and welcome to this training compilation of available data for IEA. My name is William LaFarge. I work for IFREMER, the French National Institute for Ocean Science and Technology. I am a GIS analyst and a marine data manager. In this training, I will give some tips to trust an existing data and how we proceeded to compile available data relevant for IEA in a dedicated catalog. Research activities involve process for acquiring new knowledge or understand existing knowledge. In Mission Atlantic, mapping, modeling, and developing indicators are some of research activities necessary for the evaluation of the ecosystem components most at risk from natural hazards and human activities. A compilation of various existing and relevant resources is a mandatory step to conduct these research activities. The compilation took part in the first phase of the IEA loop, the scoping. Resources are, firstly, data such as GIS layers, global product, model data, etc. Databases, programs and projects, tools, for example, ERCODE or classification, and scientific articles. Relevant resources are compiled and stored in a metadata base. And now the question is how to trust an existing data. Well, one of the most important resources is data. Good quality of data is fundamental for an acknowledged analysis, and we must consider that millions of oceanographic data are available from different sources. Firstly, I advise to search data from international databases because this ensures the quality, compatibility, and coherence of the data from many sources. These databases adopt standardized methodologies for data checking. Also, it dedicates part of the activities to prepare regional and global statistical graded products from datasets made available by the providers. For example, we have IMONNET, who provide an easy and free access to a wealth of marine data, metadata, and data products. It covers 7 disciplinary terms: bathymetry, geology, physics, chemistry, biology, seabed habitats, and human activities. Another example is SeaDataNet, who is another efficient distributed pan-European marine data management infrastructure for large and diverse datasets of physical, geophysical, geological, biological species data. All data are from sensors on board of research vessels, drifting platforms, satellites, etc. Another example is OBIS, a global alliance that collaborates with scientific communities to facilitate free and open access to biodiversity and biogeographic data and information on marine life. And the last example is to get directly your data from your National Oceanographic Data Center. Secondly, by verifying metadata, which is not data itself, but information about the data. You can see the list of information to verify where data come from and its quality. For example, a title, a description, the author, data quality, spatial information for GIS data, temporal distribution, reference, I mean the sources, and the distribution, the license and condition to use. The compilation of existing and relevant data for IEA has been done in collaboration with case studies leaders and data experts. The goal is to share the resources collected by providing an easy access for Mission Atlantic partners and other scientists. The first step is to understand the data needs to support analysis and research activities during the scoping phase. For that, a questionnaire with customized question and oriented answer is helpful to understand the needs. For example, will you work with biological data or physical data? Do you need raw data from in situ sensors or data products? Do you already have your data you need? If yes, is it available or restricted, etc. The second step is to set up a list of relevant data platforms, networks, and databases. This could be helpful for data experts searching data for IEA analysis and research activities. The third step is to closely collaborate with data experts to compile resources they found. For that, we use a common spreadsheet to get the information about the resources. And the last step is to store all resources collected in a metadata catalog, which is the result of the compilation. The large majority of resources is data. 164 data including spatial data product, biological data, modeling data, socioeconomic data, and environmental data. Then we compile 91 databases, 44 programs and projects, 34 tools, and 18 scientific articles. This compilation helps to advance the operational readiness level for IEA and considers disparities of resources available in each case studies. Celtic sees if the area with the most of resources available because maybe research activities have already been carried out in this area. It is therefore useful for highlighting data gaps and guiding future research and activities at sea. The metadata catalog is presented as follows. It offers such tools to find a data with specific vocabularies. And here you can see the metadata collection. The catalog is compliant with international standards such as IESO for metadata standards, Open Geospatial Consortium standards for interoperability, and services on the web to make data fair, fundable, accessible, interoperable, and reusable. You are welcome to visit this metadata catalog and its resources here. And this is the Mission Atlantic GeoNote dedicated for results of research activities. You can also access to this catalog directly from Mission Atlantic website in the tool tab. Thank you for watching this training. Bye.